So what do you mean by excitation table? This in while designing this excitation table, you may know that in your first year you know that what is the excitation table of SR flip flop, JK flip flop, T flip flop, or D flip flop. But how to design the excitation table? There are some basic steps you need to be followed. So we'll see how to design the excitation table for the different flip flops. Now, what do you mean by excitation table? So sometimes there is a need to find the input condition from the given output conditions. We need the excitation table. Now the input condition is nothing but what? If you are consider the examples of JK flip-flop, in JK flip-flop the input conditions is nothing but depends on your J and K variable. So the input condition is depends on J and K variable, where the output conditions is depends on your Q and plus one, that is present state and the next state. So input condition is nothing but JK variable, output conditions you can consider present state and the next state. So if the present state and next state of your circuit are specified, it means that if you know the value of your Qn and Qn plus 1, Qn is represented for the present state and Qn plus 1 is considered for the next state, then we have to find all possible combinations of your input condition to cause the desired transitions of the state. So if you know the value of Qn and Qn plus 1, you need to calculate the combinations of your input conditions. Input condition for, if you consider J flip flop, so you need to calculate the value of your J and K. It means that if you compare with the truth table, so in truth table the input part is the J and K and the output part is your Qn plus 1. But in this case, excitation table, we can say it's a reverse of your truth table. We know the output part, that is Q and present state and Qn plus 1. So this is a considered as an input for the excitation table. And what is the output? Your J and K variable is nothing but the output. Now we'll design the excitation table for each flip-flop, different types of flip-flop. Now consider the examples of your first SR flip-flop. See, whatever the steps we are using, we are actually using the 3 steps. Out of these 3 steps, basically 2 steps we need to use, same 2 steps we need to consider while we are having a topic, when we are discussing the topic convergence of one flip-flop to another flip-flop. So first step is you need to write down the truth table of your SR flip-flop. So where in this truth table, SR is there, 0, 0, 4 combinations, then the output value is Qn plus 1. Now the output part is, this is a no change, or it is when the S and R value is 0, 0, your flip-flop will be reside in the previous state, and previous state is Qn. Then 0, 1 combination is 0, 1, 0, 1, and when the 1, 1 situation, it is considered as a question mark for the race around conditions. So this is your truth table. Now this next consider as a next state table or the characteristic table. This is a new for you. Okay, so how to design this characteristics table? Okay, this table we require, characteristic tables we require in a convergence of one flip-flop to another flip-flop. So how to design the characteristic table? So the input part for the characteristics table is considered as your whatever the flip-flop you are considering. So the flip-flop input, so write down the flip-flop input as an R and write down the present state. So present state is indicated by Qn. The same thing, same step you need to follow each and every flip-flop while designing the excitation table. So SR, this is the input of your flip-flop, and Qn is considered as a present input. So here now how many inputs are there in this table? One output part we need to calculate the next state. Next state is represented by Qn plus 1. This is very important thing. So how many variables are there in input side? There are 3 variables. If it is 3 variables, so total number of combinations are 8. So write down 0 to 7 combinations. So 0, 0, 0, then 0, 0, 1. In this way, you need to write down total 8 combinations, that is 0 to 7 combinations. Fine. Then how to calculate this qn plus 1? So the qn plus 1 value can be considered, we can take the reference of this truth table while writing this value. Now, so when the S and R value for first combinations, check here, when S and R value is 0, then what is the output value for the Qn plus 1? Qn plus 1 is depends on the Qn. Now for here, that's why the Qn plus 1 value is this one 0. How it is 0? Because when if you considering the SNR value, when SNR value is 0, 0, your output value, that is Qn plus 1, is depends on the Qn, and now in this combination the Qn value is 0. In this combination you can consider the Qn value is 0. That's why your output is considered as a 0. Now next again, SR value is again 0 and 0. If it is SR, see in the truth table, if it is SR is 0, 0, again it is depends on your output value, is depends on the Qn. So here in this case Qn is 1. So your next output value will be a 1. Okay, fine. Now third combinations, S is equal to 0, R is equal to 1. Now when S is equal to 0, R is equal to 1, the output value is 0. So it does not depend on your Qn value. So output value directly you can write down the 0. So you are getting, again check, S is equal to 0 and R is equal to 0. So again it is 0 value. So again the Qn plus 1 is 0. Now when S is equal to 1 and R is equal to 0, so this is nothing but 1 0 combinations. Your output value is 1. So here it is not depends on your Qn, directly you can write down the 1 value. Again combinations of your S and R is 1 0, so output value should be a 1. Now next combination, S is equal to 1, R is equal to 1. This is a question mark. Okay, so write down the question mark here, that is race around condition. Again 1 1 value, so the race around condition. Now this is your characteristics table. So the while designing the characteristics table, what we are considering, we are considering the input of your flip-flop, and third input we are considering as a present state. Total number of combinations you can write down as per your number of variable. Then write down the Qn plus 1 value. How we are writing this Qn plus 1 output value? We are taking the reference of your truth table while writing this one. Now last step is excitation table. So how to design the excitation table? Now what is the requirement as an input? What we are considering excitation table? We are considering the Qn and Qn plus 1. Qn is nothing but your present state, and Qn plus 1 is nothing but your next state. So if there are two inputs are there, so total combinations are 4 0 0 0 1 1 0 and 1 1. Okay, now for designing this excitation table, you need the characteristic table. Without the characteristic table, you cannot design the excitation table. Now consider the Qn and Qn plus value from this table, and for respective Qn and Qn plus 1 value, you need to write down the SR value, okay, from this characteristic table. Now find out where the Qn and Qn plus value is 0 0 in this table. Okay, so if you observe here this column, last two column, here the Qn value is 0 and Qn plus 1 value is 0. Now you can observe last two column. In this last two column, there are two combinations, 0 0 combinations of your Qn and Qn plus 1. Okay, out of these 8 combinations, there are 2 combinations where they are getting the same value for your Qn and Qn plus 1. Now for these 2 combinations, what is the value of S? Now here you can check the value of S is 0. For this combination, the value of S is 0. So in both combination, these combinations, the value of S is equal to 0. Then write down the S is equal to 0 here. Now check the value of your R. Here R is 0 and the R is 1. The input combinations are changed. For these two combinations, the input combinations are changed. If the input combination is 0, 1 or 1, 0, while writing the excitation table for that, we need to write down the cross sum. If it is equal 0, 0 or 1, 1, then write down this value. If it is the value is 0, 1 or 1, 0, then you need to write down the cross sign because it is either 0 or 1. So don't care is used to for this representation. Okay, fine. Now check the 0, 1 combination from these last two columns. Okay, if I'm check 0, 1 combination, so only one combinations where we are getting the 0, 1 value for Qn and Qn plus 1. So what is the respective S and R value? So S is equal to 1 and R is equal to 0. So write down here 1 and the R is equal to 0. Now next 1 0. Check the 1 0 combination from this last two column. Now if you see out of this 8 only one combination is 1 0. So what is the value for S and R? S is equal to 0. So write down S is equal to 0 and R is equal to 1. So write down the R is equal to 1. Now last one 1 1 situation. So if you check last two columns, there are two combinations we are getting. This blue arrow indicates where you are getting the 1 1. Now here consider the value of R first. So sorry, consider the value of S. So in this case S is 0 and S is 1. S is 0 and S is 1. That's why if it is 0 1 combination, so for that purpose we are writing the cross sign. Okay, now check the value of R. Both cases 0 and 0. Okay, so write down the value of your R. So this is the final excitation table of your SR flip-flop. We are designing the excitation table with the help of characteristic table, and the characteristic table is designed with the help of respective flip-flop truth table. Okay, so in this way you can design the excitation table of any flip-flop. So this is the excitation table of your SR flip-flop. Now check the excitation table of your JK flip-flop. So first step is same. We require the truth table. So first three entries same. Last it is nothing but your QN bar, or that is toggle condition. Now design the characteristic table with the help of this one. So what is the input part? J and K is the input. Third input is considered as a QN present state, and the output part we are considering as a Qn plus 1. Now, so first combination 0 0. If you check 0 0, it depends on Qn. What is the value of Qn? Qn is nothing but 0. So here we can write down the output as a 0. Again 0 0 combination, it depends on Qn. Here the Qn is 1. So write down the Qn value. When 0 1 combination, output value is 0. Don't consider now this column. Just 0 1 combination. As per truth table, output value is 0. So write down the 0. Again 0 1 combination, output value is 0. Now 1 0 combination. For 1 0 1 combination, it is 1. So write down the output value is 1. Again 1 0 combinations, output value is 1. Now, when we are considering the 1 1 value, so if J is equal to 1, K is equal to 1, it's a toggle, that is Q and bar. It depends on Q and bar. Now here if you observe, the Qn is equal to 0. So we need to calculate the Q and bar. Q and bar for this case is 1. So write down the value of 1 here. Because this it depends on your Q and bar, that is toggle condition. Again 1 1 situation, so it depends on the Q and bar. But for this case, Qn is 1. So Q and bar will be a 0. So write down this 0 here. Now in this way you have to complete your characteristic table. Now, next one finally is your excitation table. So again, same Qn and Qn plus 1, that is present state and next state. You need to write down the combination 0, 0, 1, 0, 1, 1, 0 and 1, 1. Now calculate the value of j and k. So with the help of characteristic tables, you need to calculate the value of j and k. So first combination, check the first combination. So for these two situations or the possible combination, the output value, sorry, input value of j is 0, 0. So write down this 0, and for k is 0, 1. For k is 0, 1, so it is considered as a cross. Next one is 0, 1 combination. Now check 0, 1 combination. So for these two cases, 0, 1 combinations of your last two column, so their output value j is, both cases j is 1 and 1. Here k is again 0 and 1, so cross sign. So j is equal to 1 and k is equal to cross sign. Next, 1, 0 combination. Now check the 1, 0 combination. This 1, 0 combination, again second combination. Now here the value of j is 0, 1. 0, 1 means cross sign, and the k is 1. Both cases the k is 1. So write down the k is equal to 1. Last combination. Okay, so there are again two cases. So the value of j is 0 and 1. So 0 and 1 is nothing but cross sign. And for k, it is both cases. In both cases, the value of k is 0. So write down the value of k is equal to 0. In this way, you can complete your excitation table of JK flip-flop. Now the excitation table of your D flip-flop. Now this is a simple one because it requires only one input. So here the truth table of D flip-flop is this one. Now characteristic table, you require the input of your flip-flop, present state, and as output we are considering this Qn plus 1. Now here, if you observe, Qn plus 1 is depends on your D input. If it is D is equal to 0, then it is 0. If it is D is equal to 1, then it is 1. So here you can write down as it is column of your D flip-flop. So here D is equal to 0, that's why it is 0. D is equal to again 0, then 0. D is equal to 1, then it is 1. When D is equal to 1, again it is 1. So just you can, whatever the D column as it is, you can write down in the Qn plus 1. Now the excitation table. So present state and the next state, only one input of this flip-flop, required the one input for this flip-flop. Now check the input combination 0, 0. Here first combination is 0, 0. Here value is 0. Then 0, 1. If you consider this is nothing but your 0, 1 value, the respective input value is 1 for D. Again 1, 0. This is a 1, 0. For that 1, 0, the D is equal to 0. And 1, 1. If you are considering 1, 1, so 1, 1 is nothing but your, again 1 is there. So here you can write down 0, 1 and 0, 1. That is your excitation table. Otherwise, while writing the excitation table, you can use the trick, that is whatever the Qn plus 1 column value, you can just write down in this one as a D value. Last flip-flop excitation table. So truth table is this one for the toggle flip-flop. Then the characteristics table. So while when t is equal to 0, your output value is Qn. Here Qn value is 0, so it is 0 as per truth table. Again t is equal to 0, your output value Qn plus 1 is nothing but Qn. Here Qn is 1, so next value is 1. When t is equal to 1, Qn plus 1 value is a Qn bar. Now Qn is 0, its bar is nothing but 1. So write down the 1 value. Again t is equal to 1, so write down the Qn1 as output. So here Qn is equal to 1, so the output value is 0. Now the excitation table. Okay, only one variable, input variable. So see the combination 0, 0. So what is the value? It's 0. Then 0, 1 combination. What is the value? Is 1. Then 1, 0 combination. What is the value? Is 1. And then 1, 1 combination. What is the value? Is 0. So this is the excitation table of your T flip-flop. Now while writing the excitations of T flip-flop, what present state and next state, one trick you can use, whatever the output of your XOR gate. If you observe, output of your XOR gate is nothing but the T flip-flop, right? Okay, because in XOR gate, what happened? This is a truth table of your XOR gate, right? Okay, when the both inputs are same, then the output is 0, 1, 1, 0. If the inputs are changed 0, 1 or 1, 0, your output is a 1, 1. So if you not recall this excitation table, at least you can write down the truth table as an excitation table for T flip-flop. So this is the final excitation table of each uh, all flip-flop. Okay, combined table it is considered. Now here the input is same, that is you can consider as a qt variable or qn variable, no problem. Now here qt variable is considered. Normally we are considering the qn variable. So here you can observe 0 0 0 1 1 0 input combination. Now here you can see here, so if you not recall the excitation table directly, so at least for this D flip-flop, we can say that that is a trick. Whatever the Qt plus 1 value or Qn plus value, we can write down as it is here. You can observe here 0, 1, 0, 1. Okay, here 0, 1, 0, 1. For T flip-flop, okay, you can write down the output of your XOR gate. So that is a truth table of your XOR gate, that is 0, 1, 1, 0. Now regarding these two flip-flop, so there is no need to recall all these tables. At least you should recall the S variable output line. Okay. So here, if you recall S variable 0, 1, 0 cross, then while writing the R value, you can just reverse this line. Okay, it means that cross will be here, 0 will be here, then 1 will be here, and this is a 0 will be here. Similarly, for JK flip-flop, just recall the value of your JK line and reverse this line while writing the K variable output. So here cross, this is a second cross, then this is will be a 1 and this will be a 0. So in this way, you can recall the excitation tables of your flip-flops.